piecewise function looks like? Yes, right? This is an example of what one looks like. It's like a graph that's in pieces, hence the name piecewise functions. So that's what goes in your first blank. Oops. A function that is written using two or more expressions is called a piecewise function. I'll move some of this stuff. Alright. The first thing we're going to be doing is not graphing piecewise functions yet. I just want to start with evaluating them. And we've worked with evaluating functions before. Here's the function that we're going to be working with. These are called what I like to call restrictions. Write restrictions up top. So for this piece, we're only talking about where x is less than 0, and name some numbers that would contain. -1, -2. This one we're only talking about when x is greater than or equal to 0, like 0, 1, 2, and 3. So when it says f of -2, it wants you to plug it in to which piece? The top one, because -2 is less than 0, correct?
Yes.
So the function that is dealing with this restriction is x squared, and they want us to replace what with x squared?
-2.
Very good. So -2 squared is what?
+4.
Very good. Does anybody know what f of -2, what is the -2 if we're talking about like on a coordinate plane? This -2 we plugged in for what? X. That is our x coordinate that they just gave us. We just found it's what? Y coordinate. Good. So if you were to plot this on a graph, it would be at -2, 4. Just so we're clear.
So is that part of the answer, or is it?
No, I was just explaining this is the x and this is the y value.
Okay.
Alright, so for f of 0, which piece do we plug this into?
The second one.
Yes, because 0 is equal to 0. So we plug in 0 right here and we'll get 0 plus 1 gives us 1. So as a coordinate point, you don't have to write it down, but this coordinate point would be what?
1 is 0. 0, 1.
0, 1. Good. Alright, let's just do the last one together, then I'll let you do the rest on your own. Plugging in 1 to the top or bottom piece?
Top and bottom.
The bottom, good, because 1 is greater than 0. So that would give us what?
2.
Good. Go ahead and try the rest of 1 on your own, and then we'll stop and go over it. Then we'll do 2 on your own, then 4. But go ahead and do these 3 on your own, then we'll talk about the answers. Go ahead. While y'all are doing that, I forgot to pass out your bathroom passes for this month, so I'll go ahead and do that. If you didn't use your one from August, you can turn it in for your semester exam as 2 points. Okay. So would you keep it? Yes, so if you're not going to use this, keep it and use it for 2 points. If you already finished number 1, go ahead and do 2 and 3 if you're working ahead. Say that again? Oh, piecewise functions, or piecewise function. Everybody's done with the at least number 1, right?
Yeah.
All right, Miles, what'd you get for f of -4?
15.
Sweet. Kaya, what'd you get for this one?
11.
Antonio, what'd you get for this one?
12. 9.
All right. Do I need to go over how we got those, or is everybody good? You good, dear? Okay. So for the next one, let's just go over kind of this one together, then I'll let you do the rest on your own. Which piece, the top or bottom?
Top.
Top. And so is there anything to plug this -3 into?
5.
So what would the y value be? Just 5.
Oh.
Again, because there's no x to plug it into, so you just bring it down. Go ahead and do f of 2 and f of 5, and then I'll call in some people.
You said you 2 or 3.
Alright, so Justin, what would be the answer for f of 2?
1.
How'd you get that?
The count 2 minus
Very good, everybody agree?
No.
3. Yes.
No. I thought you used the top.
Good, you use the top because it this has only numbers greater than 2. We're looking for equal to 2 in this case, right? So what would our answer be? Good. Again. Alright, Logan, what'd you get for this one?
7.
Everybody agree? Yes. Alright, try these 3 on your own. Try 'em. Come on. You don't need a calculator. Yes. Yeah. 7 minus 2 is what? It's really in the 4. What are you talking about? This is saying if the number is between -6 and 8. Alright, compare your answers. So just ask people around you what they got. Don't be shy.
Which one are you?
What you got?
Negative 27, positive or negative 2, and 1 over 3.
How would you solve this solution? You asked.
Because I simplified that. Yeah.
I think you plugged into the wrong piece.
What'd you get for F of
No, you didn't. Keep going. Alright. Megan, what'd you get for f of -6? Everybody agree?
Yes.
Do we need to go over it? Alright. Kyle, what'd you get for f of 7?
2?
Good. It could be plus or minus 2, right? But if it was plus or minus 2, would it be a function?
No.
No. And we'll talk about that in a minute. Okay. F of 9, Ransom, what'd you get?
7, 3 over 9. I wasn't sure.
What did y'all get? Everybody? 22 over 3? Good. If you want to put this as a decimal, you can, because it's probably easier to graph if you have a decimal. So either one would be fine. Did anybody put it in a decimal?
Could you work that out?
Yes, I can. 7.3. I can work that one out. So f of 9 goes into which piece? 1, 2, or 3?
3.
Alright, so it's 3 over 9 plus 7. So this simplifies to what?
1/3.
Alright, and then how would I change this bottom of 1 to 3? I'd have to multiply, right? So multiply the top by 3, I'll get what? 21. And then you add the tops, keep the bottom. Alright, now that we know how to evaluate, now we can graph them. Because that's all we do. We evaluate a few points, then graph those points. And just like I said, this is your what value?
Y value.
No,
Oh, that's the
X
right
value.
Y
This is your Y value, okay? So for piecewise, we're going to make 2 different tables, okay? Go ahead and make an X and Y table for each piece. And I'm going to show you this way how to graph them, and then I'm going to show you another way. There's 2 ways to graph piecewise functions. Alright, and the numbers we're going to use for X, we're going to use our restrictions to do that. So for this one, what's the number less than 2?
1.
Alright, another number less than 2? And another one.
-1.
I just want you to pick 3 of them. Okay? And now if we plug all those into this piece, what would the Y value be for 1
-3.
and for 0?
4.
negative 4. And for 1, negative 1, negative 5. Good. Alright, for this piece, we can start with 2 because it's equal to 2, correct? Now give me 2 other numbers. 3 and 4. What would the y value be for all of these? 1 for all of them. Alright, one more thing before we start graphing. On this first piece right here, we'll need to include this 2 in our graph, and I'll explain why. So put 2 down here at the bottom. And if I plug 2 in, I'll get what here?
4.
No,
-2.
negative 2. What's 2 minus 4, Antonio? Don't play with me. Alright, if you were doing like a number line, inequality, would this have an open or closed circle?
Open.
Good, because there's no bar underneath. At 2 on this one, would it be open or closed?
Close.
Because of the bar underneath. Do y'all remember that? Now let's graph, starting with this one.
Oh, you're doing that because on the graph it's going to be open.
So graph 2, negative 2, and put an open circle at that spot. 2, negative 2, and put an open circle.
Did you put positive, negative, because this right here?
Yes. Then graph all of these dots, and these can be closed. So negative 1, negative 5, negative 1, negative 5, 0, negative 4, and 1, negative 3. See how it's going to make a straight line? It's going to start wherever your open or closed circle is. That came from right here. And then it's going to go through the rest of the points. So go ahead and draw that line. That's your first piece. Zoom out a little bit, sorry. Alright, for your second piece, start at 2, 1. It should be a closed circle. And then graph 3, 1. And 4, 1. And you can see this is where it's going to start, where x is 2, and it's just going to go straight across. And that's it. Now, that was kind of a lot of work to just grab 2 pieces, right? So here's an easier way. If you just want to graph these 2 points, find out what these are, and graph them, then you could just look at the slope of each piece. Y'all remember what slope is? Think of this as y equals x minus 4. The slope is what here? 1. So you could have graphed this one, and then gone down 1, back 1, down 1, back 1, because a negative 1 and a negative 1 make a positive 1 as far as the slope goes, right? If you can't remember that, just make a chart. And this one, the slope is what if it's just y equals 1? What's the slope of a horizontal line?
Horizontal?
Yeah.
Oh, undefined.
0.
Oh, 0.
Good, so it'll be a flat line, a horizontal line.
I did say 0.
You said undefined.
On the first one, I said 0.
Don't play with me. Flip it over. Let's do one more together, then I'm going to let you do the last 2 on your own. Alright, on this one, make 2 tables, and we'll just try the 1 dot thing. And if we can't get it, then we'll make multiple points. Alright, the first x in each one needs to be negative 1, because that's what's in our restriction. Alright, what would you get if you plugged negative 1 in to the top? 2, good. And this one, if you plug negative 1 in? Negative 2. Alright, Darian, open or close circle for this first one?
Close.
And then for this one? Good. I want you to go ahead and graph those 2 dots first. So negative 1, 2, put a closed dot. At negative 1, negative 2, put an open dot. Do y'all want to try to use the slope to move instead of doing multiple points?
I reckon multiple points.
Okay. We'll do that. Let's talk about the slope first, then I'll go back and do multiple points. What's the slope of this one, everybody?
1.
1. So from here, I would go what? Up and over 1. Up and over 1. Up and over 1.
How many points do we need?
Just 3 will be fine. What's the slope right here? 2. And the slope's always the number beside x, in case you forgot. Now we can't go up 2 and over 1, right? But we can go what? Down 2, back 1, down 2, back 1. Now for those who are not comfortable with using the slope, let's talk about how we could have done that using other points. So Antonio, what are numbers that are less than -1?
I got -2 and -3.
Alright, and numbers that are greater than -1?
0 and 1.
So what would be this if I plugged it into my first piece?
1,
And
0.
And see here, -2, 1 would be right here. Maybe I'm looking at the wrong one. Greater than -1. Let me look at this one. Go ahead and try 6 and 7. I don't know why this isn't working.
That's right, Jimmy.
I know the points are right. Just on here, the graph would be going over here, and I'm not sure why. Let me go back to this. 2. Oh, let's go back and look at 5, guys. I don't have any whiteouts. Let me do this. Let me get another sheet of paper. Messed up on this one. Or I messed up. Y'all didn't mess up. Because the chart was right and our points are right. Let me do this again. -1 and 2 is correct. This is correct. This is for the restriction x is less than or equal to -1, correct? This is for x is greater than -1. So when we graph this point like y'all did, -1, 2, the line needs to be going which way?
Down.
To the left. Everybody see that? How the arrow is pointing to the left? So this slope was 1, so we needed to go what? We couldn't go up 1 over 1.
You gotta go down.
Yeah, we got to go down and back. Sorry, guys. If you wrote in pen, I apologize. Everybody see what I'm saying there?
Does that mean the other one should go up?
Yes. So after we graph -1, 2, and it's an open circle, -1, -2, this line should be going this way, because this is which way the arrow is pointing. So from here, the slope was what? Yes, up 2 over 1. I'm so sorry.
How'd you get 4 points for that one?
How did I get what now?
4 points for that one.
How did I get 4 points?
No, no, on the graph.
Right here?
No, yeah.
You can graph however many, 3 points, 4 points, it don't matter.
So your less than greater than sign determines which way it goes.
Yes. Like on this one, if I flip back to it.
So we did 4
No, we did number 4, right? See, this one, the second line should be going this way, and it is. And the first line should be going to the left, and it is. Alright, try the other 2 on your own. And if you need help, let me know. Alright, let's start on this on Tuesday. You can pack up, sorry. I was not sure.
Yeah, school Monday.
Hey, Derek, here. You're not in trouble. Who's the last time you guys went back there? Yeah. And you tell me he did that on it? Because he didn't come back? Did that happen? Okay. Now now he's got to the bathroom in the morning. It is true.